Welcome back everyone. I hope you all are fine. Today our topic is an electric current. There's the important topic in the current electricity. There's previous we can learn the static electricity. So what is the difference? We can know the difference between electric and static electricity. So our today learning outcomes that uh, That's learning outcomes define electric current as the charge passing a point per unit time. Recall and use the equation electric current charge per time. That's I equal to QIT. There's describe electric conduction in metals in terms of the movement of free electrons, and know that current is measured in amps. There's and that the ampere is given by the coulomb per second, and know the difference between the direct current and alternating current, and state that the conventional current is from positive to negative and that the flow of electrons is from negative to positive. Then describe the use of ammeter, analog and digital with the different edges. That's the learning outcomes today. So what is an electric current? So an electric current is the rate of flow of electric charges in the circuit. That's the circuit. There is a battery and is connecting wire, and there is a filament. When is a key is on, there's the current. There's a electron is a flow from negative terminal to the positive terminal. It's a called a flow of electrons. For this reason, there is a happen in electric current. That's the electric current. So now we have studied static electricity. Now we consider the situation where charge can move and hence the produce an electric current. This is the cross-sectional area of a connecting wire. There's the positive charge can move in the cross-sectional area. There is a total charge move from the cross-sectional area. In the cross-sectional, there is a del q is the amount of charge del q that flows through the area is divided by the time interval. The ratio of the charge, total charge by and the time interval is delta. That's the ratio is called the current. The actual setup in the circuit, that's the picture. That's another picture circuit diagram in when we can draw in the paper. That's the circuit diagram. Describe electric conduction in metals in terms of the movement of free electrons. In metal, each atom has one or more loosely held electrons that are free to move. When a handicap generator or a battery is connected across the end of such a conductor, the free electron drops slowly along in the direction from the negative to the positive terminal of a battery. In the picture, there is a battery, there is the positive terminal, there is the negative terminal. The electrons drop slowly along it in the direction from negative terminal to the positive terminal of a battery. There is then a current of negative charge. On the other hand, the static electricity, the electron cannot be moved uh, one place to another. For this reason, that's called the static electricity. But there's a current electricity. There's an electron flow of electron is electron free electrons move one place to another when in the circuit. That's the called current electricity or current flow. There's a note that the current is measured in amperes and that the ampere is given by the coulomb per second. The unit of current is the ampere, which is defined using the magnetic effect. 1 milliampere is 1,000th of an ampere. There's 1 milliampere means 1 by 100,000, 1 over 1,000 ampere. There's current is measured by an ammeter. This ammeter is a device. Ammeter is a device that's we can measure the current by using this ammeter device. There's the current of the unit of charge, the coulomb. Coulomb, C is the coulomb, symbol of charge is C, that is defined in the terms of the ampere. So there is a 1 coulomb. There's what is the meaning of 1 coulomb? 1 coulomb is the charge passing any point in the circuit when a steady current of 1 ampere flows for 1 second. That's called the 1 coulomb. 1 coulomb equal to 1 ampere second. That's another example. There is a charge of 3 coulomb would pass each point in 1 second. That's time is 1 second, but coulomb charge is flow 3 coulomb. That's if the current or 3 ampere. When 3 ampere is current flow, there is a 3 coulomb charge is flow from one place to another in 1 second. But in 2 seconds, what happened? 3 ampere into 2 seconds. So there is a 6 ampere second. Total charge flow is 6 coulomb would pass. Know the difference between direct current AC, DC and alternating current AC. So difference in the direct current DC, the electrons flow in the one direction only. Graph for the steady and varying DC. There is a two picture in there. There is a y-axis current and x-axis time. There is a steady current is only one direction only. There is another which is varying. DC is up and down. There is the two types of this DC current. In alternating current AC, the direction of flow reverse regularly. That's up and down. Means as shown in below the graph, figure 1, the circuit sign for AC is given. Figure 2. The pointer of an ammeter for measuring DC is deflected one way by the direct current, but alternating current makes the pointer move to and fro about the zero if the changes are slow enough. Otherwise, no deflection can be seen in the ammeter. This battery gives a DC current. DC, but generator can produce either DC or AC. That's the sign of alternating current. There is up and down positive cycle and negative half cycle. There is a two half cycle complete one cycle. That's happen in half second, 0.5 second. There is another complete cycle. There is a total time is a 1 second. There is a 2 cycle is complete. For this reason, the frequency is at 2 hertz. 2 hertz. The frequency is 2 hertz. Though it's the another figure is a sign for AC. Circuit sign for AC is the figure 2. There is a conventional current and electron. What is the difference between the conventional current and electron flow? If there is a battery 1.5 volt here. There is a positive terminal. There is a negative terminal. That there is electron flows from a negative terminal to the positive terminal, and current flows inversely. Current flows a positive terminal to the negative terminal. That's called the conventional current. There is a filament. When there is energy is from positive terminal to negative terminal, the filament is enlightened. So we learn the conventional current and electron flow is a difference between them. That's positive Conventional current and electron flow are vice versa. That's an ammeter. An ammeter is a device. Current is measured using an ammeter. An ammeter has very low resistance to current and so does not affect the current in the circuit. It simply measures it. An analog ammeter, there is an analog ammeter, gives a reading with a needle moving across a scale. There is the needle needle moving across the scale. It's a digital ammeter has a numerical reading displayed. The analog ammeter below shows a current of 0.5 ampere. There is a zero point 0.5 ampere current flow and measured the analog ammeter. But the digital ammeter below shows a current. There is a current of 1.26 ampere. So the ammeter is always placed in series circuit with other component in the circuit. So that's the current electricity concept. Thank you for watching our videos and subscribe our YouTube channel.